everyone, welcome to the detailed video on one of the most fundamental operations in the binary morphology, that is the hit and miss transformation. In the field of image processing, especially binary uh, image morphology, the hit and miss transform plays a vital role in detecting specific patterns and analyzing structural features in binary images. It serves as a fundamental operation for which other morphological techniques like erosion, detailation, thinning, and thickness are derived. So in this video, we will cover the following. That is what is hit and miss transform, how does it work using the structuring element, and applications and guidance for using the technique effectively. So we will also discuss how the operation integrates into more complex morphological tasks and provides example to illustrate its power and versatility. So the hit and miss transform is a general binary morphological operation that identifies specific pattern in a binary image. It operates on binary images and uses structuring elements to detect foreground and background patterns. Unlike other binary morphological operations, this method takes into account both foreign pixels and background pixels. So foreign pixels are represented as ones and background pixels are represented as zeros. The output is another binary image highlighting the matching pattern. So thin of its search and match tool, scan an image pixel by pixel to find the areas that matches a predefined template. This operation is particularly useful for detecting patterns like corners, edges, endpoints, or even isolated points. So next is how does it works. Now let's dive deeper into how does the hit and miss transformation work. So a structuring element is especially a small predefined pattern made up of one and zeros. So it is applied to the image in a sliding window fashion, comparing the pattern with the undetailing pixels in the binary images. So ones in the structural element must match the foreground pixels in the image. Zeros in the structural element must match the background pixels in the image. So consider the two image. So in the image one we have some set of numbers ones and zeros, and another image it has a set of pixels that is ones and zeros. So when you start comparing that image one with the image two, so zeros must match with the zeros and ones must match with the ones. So if there are exactly match, if there is an exact match, the pixels at the origin of the structuring element is set of foreground, that is 1, the output image, otherwise it is set to the background 0. So this is slightly different from simpler operation like erosion and dilution, where zeros were treated as don't care values, but in hit and miss, every values have significance. Okay, so there we have a 3 into 3 box. So images are basically ones and zeros. So consider the same boxes, consider the same image, copy it 1 and 2. So start comparing zeros with zeros and ones with 1. So next is here is an example of structuring element used for corner detection. So there is a 3 into 3 element with ones and zeros arranged in the shape of bottom left convex corner. The origin of the structure element is placed at its center. So when applied to a binary image, the structuring element identifies the corner that matches its shape. But what about the other type of corners? To detect all corner type, top right, top left, bottom right, we rotate the structuring element to create four versions. Each version is then applied to the image individually. So apply the original structuring element to find the bottom left corners. So rotate it 90 degree, 180 degree, 270 degree to detect other corners orientation. By running the hit and miss transform 4 times with these rotated elements, we can detect all the corners in the image. Next is combining result, that is using OR operation. So once we process the image using all the four rotations, that is 90 degree, 180 degree, 270 degree, and 360 degree, all the four rotations, structuring elements, we combine the result using a simple OR operations. So the OR operation merges all the detached corners into a single output images. Pixels marked as corner in any of the four results are retained in the final output. This co consolidated result shows all the right angle convex corner in the binary image. So here is an example for binary image processed with this method. Notice how the corner in all the orientations are highlighted in the final output. So showcase the power of hit and miss transformation for pattern detection. So the first image is normal, next is rotating 90 degree, 270 degree, and at last 180 degree, and at last 270 degree. So these are the four different transformations. Okay, next is handling edges of the image. So one challenging with the hit and miss transform is handling the edge of the image where the structuring element overlap the boundaries. A simple solution is to assure that any structuring element overlap the pixels does not match the undirectly pixels. As a result, the corresponding output pixel is set to 0. This approach ensures that the transform remains accurate and avoid errors at the image boundaries. It is an essential detail to keep in mind when implementing the operations in the real world scenarios. So next is the applications of hit and miss transform. So hit and miss transform is incredibly versatile. So one is in corner detection. As we see, it can detect right angle convex corner in binary images. Next is isolated point detection. Isolated point detection means structuring elements can be designed to locate single isolated point in an image. Next is endpoint detection. This involves finding the endpoints of a binary skeleton. Next is junction detection. Uh, the transform can identify triple points where three lines meet on the skeleton. Thinning and thickening. These operations are crucial for skeletonizing and boundary enhancement and are derived from the hit and miss transform. By combining this transform with a simple set operation, we can perform a wide range of complex uh, mon- morphological tasks. Next is isolating point detection. A simple 3 into 3 structure element with a single foreground pixel 1 at the center can locate isolated points in an image. Next is endpoint detection. A structured element designed to match endpoint on a skeleton must be rotated in all four orientations. This represent four passes of hit and miss transform. Next is junction detection. To locate a triple point on a skeleton, three different structuring elements are used. Each structuring element must be applied in four orientations, resulting in total of 12 pulses. So these examples demonstrate how structuring elements can be trailed for specific pattern, making the hit and miss transform a powerful tool for binary image analysis. So that is a different four transform. Okay, next is so this is an example for using the hit and image transform on a skeletonized binary image. So first we apply the transform to locate the points. So the resultant highlight these points as single pixel foreground marks. To visualize the result more clearly, the output is detailed with a cross-shaped structuring elements. Finally, the dilated output is overlapped on the original skeleton to show the uh, detected triplet points. So you can see at the image 3C, there are three different triplet points or also known as junctions. This process demonstrates how prescribed and effectively the hit and miss transform is for analyzing complex binary structure. So at the conclusion, so to wrap up, let's recap what we have learned about the hit and miss transform. So it is a fundamental binary morphological operation used to detect specific pattern in the image. So its structuring element include both foreground and background pixels. Foreground pixels means 1, background pixels means 0, making it more versatile than traditional erosion or detailation. Application include corner detection, skeleton analysis, thinning, thickering, and more. By combining it with a set of operations, we can perform a wide range of advanced image processing tasks. The hit and miss transform is not just a tool, but a gateway to understand and implement complex morphological techniques. So, thank you.